Geometry, trigonometry, and all of those wonderful stuff. Come on, people. Praise God. Nice and easy. Just give thanks for these easy questions. Now it says the diagram below is not drawn to scale and it shows the relative positions of 3 reservoirs, BFG, on a level ground. The distance between BF is 32, FG 55. The angle BFG is 103. F is on a bearing of 42 degrees from B. It says determine the bearing of B from F. So it's always, I always look out for this word, guys. This is the key word in bearings, from. Determine the bearing of B from F. So it's always the from position. So the bearing of B from F is going to be all of this angle. The bearing of B from F is all of this angle. That's the bearing of B from F. It's always the from position. So we need to know what this little angle is that to draw right here in order to get the bearing B from F. We need to know that little piece right there. Now, we can easily find out this little piece right here. How are we going to decipher this little piece right here? So let's do that now. Let me just draw this diagram a little more accurate. Use some arrows, make it look straight and nice and neat. So it's the from position. I like when angles just almost look like, even though it's not drawn to scale, I like when it just, you know, it just simulates what you're supposed to have. You know, I just like when it's simulating everything. All right, so B from F. And the bearing is going to be all of this. B from F is all of this. So we need to find this angle. All right, now, if I were to continue to extend this line going down, right? Continue to extend this line going down, then what can I see? What can I see? Let's decide what can we see to find this little piece right here. All right. Now, if I were to draw broken lines going across, right? If I were to draw broken lines going across, look what I'm saying, it's going to make sense. If I were to draw broken lines going across, then I would know that this angle right here would be 90. And if this angle here is 90 and this is 42, then I would know what this angle is. This angle would be 48. This angle would be 48 degrees. Now, if this angle is 48 degrees, right, and I know coming all the way around here, right, is, yeah, so we're done. We're basically done because we know that this is 48. Now, if we know that this is 48, then we know that this angle right here is 48. I don't know why I always like to find everything one time. All right, so this angle right here is 48, and so you can even write down what this angle is if you want. So you can write that that is 48 plus 103 and 180 minus answer. So this angle right here is 29. This angle right here is 29 degrees. I don't know why I like to write down all of this stuff. All right, and this is 90. Now, all I'm saying is all of this plus this angle right here, I'm going to give you 360. So this angle right here is going to be 360 minus 90 plus 48 plus 103. So this angle right here is 119 degrees. This angle is 19 degrees. So what am I actually saying to you? The bearing of P from F is equal to 119 plus 103. 119 degrees plus 103. I know I probably did it a longer method than what you would have identified, but that's the beauty of mathematics. If you can see now it says 270 minus 48, big up yourself. All right, but I had to break it down like that. So 119 plus 103, that's 222. 222 degrees. That's the bearing of B from F. What next they're gonna ask for? We don't know yet. They want us to find the distance BG to 1 decimal place. Find distance BG. The distance BG, we can use cosine rule, because we know this side, we know this side, and we know the angle. So we can use cosine rule. Using cosine rule, we know that BG squared is equal to the first side square, which is 32. The sides are 32 and 55, and the angle is 103. So using cosine rule, BG square is 32 square plus 55 square, 32 square plus 55 square plus 2 times 32, oh, not plus, minus is cosine rule, right? Minus 2 times 32 times 55 times the cosine of 103 times the cosine of 103 degrees, cosine of 103. And that's going to give you BG squared. So when you work this out, you're going to get that BG squared is equal to, put all of that in a calculator, 32 square plus 55 square minus 2 times 32 times 55 times the cosine of 103, and you get BG square is 4840, and so you square root it to get BG, and so get that BG is equal to, when you square root it, square root your answer, you get BG is 69.6 kilometers. I think it was kilometers, 69.6 kilometers. And that's how you get BG. I think it was kilometers. Let me check again. Yes, it's kilometers. Now there's another way you could get BG, you know, look, you could use sine rule. You could use sine rule to say 55 over 48. You could even use sine rule and say 55 over the sine of 48. 55 over the sine of 48 is equal to BG over angle that goes with BG is 103 over the sine of 103. All right, and then what you do is make BG the subject by multiply through by sine 103. So you get that BG is equal to 55 times the sine of 103 over the sine of 48. You can use sine rule, guys. Use up your sine rule, use up your cosine rule, use up your trig ratios, every little thing that you know. You don't want to be studying them all year and just use one formula. Imagine you study sine and cosine rule all year to use one formula. Use up your sine rule. So use a sine rule and you get BG is 55 sine 103 divided by the sine of 48, and you get your answer for BG. You get your answer for BG, nice and easy. All right. Now, of course, I did some rounding now, so you won't expect to get the exact same value, but you should be good as well. All right. Nice and easy. Yeah, 69.6. Just checking that cosine rule is correct. Going all the way around here. Just checking the formula that I didn't apply anything incorrectly for cosine rule. Nice, didn't apply incorrectly. Okay, let's go back now to page, where were we, page 30? Oh no, we weren't at page 30, not yet. Then it says calculate the nearest degree the bearing of G from B. Find the bearing of G from B. So it's the from position. The bearing of G whoa. Going straight, this is not necessarily 48. This is not necessarily 48. All right, so ignore that right there. That's not necessarily 48. Because right here would be a, yeah, that's not necessarily 48. All right, so this is not necessarily 29. How did I end up with 48 here? I was trying to use Z angles. Why can't I use Z angles there? My apologies. So we want to determine the bearing of, so remember, we just find out that BG is 69.6. I want to determine the bearing of G from B, the from position. So G from B is 42 plus this angle, let's call it theta. So we need to find theta. There are many ways we can find theta. We can use sine rule, we can use cosine rule, we can use so many things to find theta. All right, in my estimation, the easiest way to use is sine rule. Cosine rule, they have square and too much something are going with cosine rule. So go find this angle theta. To find this angle theta, what we are going to do is, remember, the side opposite corresponds to this angle. So this 55 corresponds to sine theta. And that would equal to, I'm going to work with this side that I know, 69.6 over the sine of 103. So using this now, and we transpose to find theta, we're going to cross multiply, and so we're going to get sine theta is equal to, when you work it out, right, 69.6 over sine 103. So work out what is this, and then you divide it by 55. Work out what is this. Or another way you can do it is work out sine 103 times 55 and then divide it by 69.6. So 55 times sine 103 divided by 69.6. And so sine theta is 0.76. 0.76. But we want theta. So we use sine inverse to get theta. And so theta is sine inverse the answer. we get 50.3 degrees. Yep, I know it wasn't 48 because when I look at it, it couldn't be 48. That's 50.3. So theta is 50.3 degrees. Now that theta is 50.3 degrees, now we can proceed and move on. Now that we get that theta is 50.3, the bearing of G from 8 is equal to the 42 plus 50.3. 42 plus 50.3. And that is, of course, 42 plus 50.3. That is 42 plus 50.3. That's 92.3 degrees. 92.3 degrees. Nice. Now let's move. Angle in a semicircle is 90. All right. So as you can see, we have a semicircle from AOB going around. This is a semicircle. Angle in a semicircle right here. This is 90. So this is 90. Oh gosh, this is 90. So now we're able to find ABC. This angle now, angles in a triangle sum to 180. And since angles in a triangle sum to 180, this angle is going to be now 180 minus 58 plus 90. So that is angle ACB. All right, so that one took a little while to come through. The angle ABC is equal to 180 minus the sum of 58 plus 90. That is equal to that's equal to 32 degrees. Wow. So that's 32 degrees. And the reason is AOB MC, if we want to say, forms a semicircle. And then the angle in a semicircle is 90. So angle at C is 90. Then angles in a triangle sum to 180. So angle ABC plus 58 plus 90 is equal to 180. Then from that we could find angle ABC. So that's our reason for this one. Let's see what's the next one they're gonna ask us. CMN, angle CMN. I wrote down all of them already, you know, but it came off. I think I wrote this down as 132, but this is a mistake because 132 plus 58 is not 180. Looking back at it, it should be 122. Don't give it away, that's 122. Opposite angles in a cyclic quad sum to 180, so that's 122. So CMN equal 122 degrees since opposite angles in a cyclic quadrilateral sum to 180 degrees. Nice and easy. Soft. All right. Then finally, what's the last one asking us for? NCM. NCM. What is NCM? Angle at C. NCM. NCM. This little angle here. Well, angles in a straight line is 180, so If this is 122, this is going to be 58. If this is 58 and this is 90, then C is 180. 180 minus 58 plus 90. And so angle NCM, if it's NCM, that's 32 degrees. So angle NCM is 32. Angle NCM is equal to 32. The reason angles in a triangle sum to 180 degrees. So NCM, the angle NCM is equal to 180 minus the two angles that we found, which we knew were 90 and 58. And that takes care of this nice and easy question. Now let's go to